Hello chemistry students. Today we're going to be working on packet page 13 in your green packet. It says dimensional analysis and the mole at the very top. If you read the very top of the page, it's telling you how you can change particles to mass, or number of atoms into grams, or grams into the number of atoms or molecules that there are. So that's the whole purpose of this worksheet. I'm going to do just number one for you and number two, because they kind of have the same idea. They're just going in opposite directions. So number one says, how many atoms are in 8 grams of sulfur? Well, there are a couple things that I want to write down before we actually start. And these are our conversion equations. For instance, we know that in 1 mole we have 6.02 times 10 to the 23rd atoms. We also know that 1 mole of something is equal to the molar mass. And recall that molar mass is what you guys were calculating back on pages 11 and 12 of your packet. So if you don't remember how to do that, then go ahead and pause this and review how you were able to calculate that. Anyway, back to number one. We're looking for the number of atoms that there are in 8 grams of sulfur. So first, since I see that we've got grams here, whenever you've got grams in a problem, you're going to be using the molar mass. And if you look at the periodic table, you'll find that the molar mass for sulfur is 32.06 grams. So I always just write it next to the problem, because then I don't have to keep flipping back and looking at the periodic table, and if I have to start over for some reason, at least I have that there. Alright, so fine, let's start our dimensional analysis grid. We're starting out with 8 grams of sulfur, since that's what we're given. That's what I'm going to write first. Then I draw my grid and denote the unit. So I'm going to go ahead and put grams here at the bottom. Well, if you look over here at our conversion equations, I can see that 1 mole is equal to the molar mass. Remember that the molar mass is always equal to grams. So this is going to be the first equation that I use. So I've got grams on the bottom, and I'm going to put 1 mole at the top. And as far as grams go, that's just the molar mass of sulfur, which we've already determined to be 32.06. So I'm done with that section, and I draw my line. Grams goes away. I've got moles on top, denote the unit. And I can see that I have a relationship written down between moles and atoms. So I'm going to put atoms at the top, and lucky me, that's exactly what we're looking for in the problem. I can see from my equation that 1 mole is equal to 6.02 times 10 to the 23rd atoms. Moles goes away. And in order to solve this, I'm going to multiply 8 times 6.02 times 10 to the 23rd, and I'm going to divide that product by 32.06. And once I plug that all into my handy dandy calculator, I get an answer of 1.50 times 10 to the 23rd atoms of sulfur. And this is the correct answer for number one. Alright, so I'm going to keep these two conversion equations up there at the top. I'm just going to outline them here in a new color so that we don't forget about them, because we're going to be using them for mostly the rest of this page. Let's take a look at number two. How many grams would 4 times 10 to the 25th atoms of silver weigh? Well, again, since I've got grams in the problem, this is what we're looking for now, is grams. I know that I'm going to need the molar mass of silver. So look on your periodic table. You should see that the molar mass of silver is 107.87 grams. So just like with any other problem, go ahead and start with what you're given. You have 4 times 10 to the 25th atoms. Draw your line. Demote your unit. And since we don't have an equation that goes directly from atoms to grams, we're going to have to go from atoms to moles. So I'm going to put 6.02 times 10 to the 23rd atoms at the bottom, and we know that that's equal to 1 mole at the top. Atoms goes away. I'm left with mole. That's obviously not what I'm looking for, so let's make another section. Demote the unit. And I see up here that moles is equal to grams, so I'm going to put grams at the top. I see that 1 mole is equal to the molar mass of a substance. Well, since our substance is silver, and the molar mass of silver is 107.87 from the periodic table, I'm going to put 107.87 right up there at the top. Moles goes away, and I'm left with grams at the top, and that's exactly what we're looking for in our problem. So I'm done. All I have to do now is multiply 4 times 10 to the 25th times 107.87 and divide that product by 6.02 times 10 to the 23rd. And when I do that, I get 7.17 times 10 to the 3rd grams of silver. And that's how you do those two problems. So I know that I said that I would only do 2, but let's just do one more because they're so much fun. Number 3 is a little bit different from the others in that we're only going from grams to moles. So number 3 and 4 and 5, which are just like it, they're going to be a little bit shorter because, as you can see in our equation up here, we have a relationship between grams and moles. So this is just going to be a 2-step problem. Okay, so since we have grams in our problem, we're going to need to know the molar mass of argon. When you look on the periodic table, the molar mass of argon is 39.95 grams. So in order to solve this problem, you're going to start with what you're given, 3.4 grams of argon. Draw your lines, demote your unit, and I'm going to scroll back up here so that we can see our equations. We demoted grams, and we can go from grams to moles. So I'm going to put moles on top. And lucky us, that's exactly what we're looking for in our problem. So once I fill in the numbers, I'm done with my grid. So since I've got grams at the bottom and I see that it's the molar mass that's equal to 1 mole, I'm going to put the molar mass of argon on the bottom, 39.95. Grams goes away. I'm left with moles, which is what I'm looking for in the problem. So I'm going to divide 3.4 by 39.95, and when I do that, I get my answer of 8.51 times 10 to the negative 2nd moles of argon. So that is an example for numbers 4 and 5. So you should try numbers 4 and 5 on your own. And I have to give my shout outs. So in period 6-7, I want to shout out to Alexis Johnson and to Josh Wallace. And in period 9, I want to shout out to Megan Ida and to Drew in the back row. And I also want to shout out to two people in 10th period. Those would be my 2 assistant co-teachers, Michael Balzano and Anthony Nicholas. Thank you guys. Have a good night.